Alright guys, so now we're going to be working on the following problem. It's going to be a little bit more tricky than the one we did in class, but hopefully it gives you a better idea. Okay, so the problem states the given cosine theta is equal to negative 5/12, and the parameters are from pi less than or equal to theta less than or equal to 3 pi over 2, meaning theta is between pi and 3 pi over 2. We're trying to find cosine of theta. So in my paper, let me write down all of this information. Let me write down the cosine of theta is equal to negative 5/12. So the parameters are from pi less than or equal to theta less than or equal to 3 pi over 2. And then we're trying to find cotangent of theta. Alright, important thing to know is that, again, theta stands for the angle. So this is an angle. And well, these are the parameters from 3 pi over 2 to pi. And again, we're trying to find cotangent. Also, one more thing to remember, our famous SOHCAHTOA. For cosine, we know cosine is adjacent over hypotenuse. That means that my 5 is my adjacent and 12 is my hypotenuse. So let's jump onto this problem using all of that information. Okay, so here's my problem. Here's where I'm going to be making my triangle. And let's take a look at this graph, at this x and y axis. One thing that I told you, we can have pretty much our unit circle drawn on top of this. We know our unit circle begins at 0. It goes around to pi over 2, gets to pi, and finally it goes to 3 pi over 2. Notice that my parameters stated that I can only go between pi and 3 pi over 2. That means that I can only go from pi to 3 pi over 2. These are my parameters. Or, in other words, remember that we have quadrants. This is quadrant 1, quadrant 2, and my quadrant 3. The problems will either state a specific parameter like here, or it will tell you to find it in a specific quadrant. In this case, we're finding it in quadrant 3. Now my triangle. Let me make a triangle. Again, it opens the angle there, that way, and the angle creates a triangle, a right triangle right there. Okay, so this angle here, that is my theta. That's the angle that we are given, theta. Now, I know something else. Over here, I know that cosine is negative 5/12. I only know that 5 is my adjacent side. Adjacent. And the 12 is my hypotenuse. Remember, adjacent over hypotenuse. That's cosine. Now, I'm going to use this negative 5/12. Well, based on where my angle is placed at, this side is my opposite side. That means the remaining side here, that is going to be my adjacent, and the long side, of course, is going to be my hypotenuse. Again, is negative 5/12. 12 is my hypotenuse, and 5 is my adjacent side. Now remember that it was negative 5/12. Well, the hypotenuse will always be positive. In this case, in my x and y axis, this 5 is going to the negative side. The 5 will be my negative. Also notice that here my opposite side goes down. That means this side has to be positive. Well, let's find the length of that side, and we're going to find that using the Pythagorean theorem. So it'll be 5 squared. Well, it doesn't really have to be negative. or it can be, it doesn't have to be -5. It can also be +5 because it's going to be squared, and any number squared is positive. And then that plus our missing side, let's call that b squared, equals the hypotenuse 12 squared. So we get 5 squared, or if you wanted to put the -5 squared, that's still going to be +25, plus my b squared equals 144, 12 squared. Let's subtract 25 from both sides, minus 25, and I get that b squared is equal to 119. Now we have to take the square root of both sides. We get that b is equal to plus or minus the square root of 119. That means b is equal to plus or minus, and the square root of is 10.9. Plus or minus 10.9. That 10.9 over here, well, plus or minus, going down it's minus, so it has to be minus 10.9. There you go. Like, this was the most difficult part, just finding that side. Now with this we can find pretty much any trigonometric function we want to look for. Alright, we have our opposite, adjacent, and hypotenuse. You want to find sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. We're being asked to find cotangent. Cotangent is equivalent to, let me write it actually down here. Cotangent theta is equivalent to pretty much sine theta, well, cosine theta over sine theta. Notice this, cotangent is cosine theta over sine theta. Tangent theta was sine over cosine theta. Well, that means, you know how in our SOHCAHTOA tangent is opposite or adjacent? Well, for cotangent is adjacent over opposites. So my cotangent theta is going to be equals to adjacent over opposite. Adjacent is -5, and my opposite is -10/9. Adjacent is -5, and my opposite is -10/9, 10.9. That means that my final answer is going to be this. Well, positive. This is my cotangent. Now, how did I do this? Okay, this might be a little bit confusing. Okay, I hope that you get how to find this, which is like the main thing. Again, if you were trying to find sine of theta, it's just going to be opposite over hypotenuse. Opposite is -10.9, and my hypotenuse is 12. That's it. If you were trying to find tangent theta, that's just going to be opposite over adjacent, so that'll be -10.9 over the adjacent, which is -5. Alright, now for cotangent, it was just the same thing as tangent, but backwards, the reciprocal. For sine, we have opposite over hypotenuse. You know the cosecant? Cosecant, it's 1 over sine. Well, then cosecant theta, it'll be just the reciprocal of this one, which it'll be 12 over -10.9. Same thing for secant, same thing for cosine and for secant. Alright, and that's it.